Imagine this. You're on a bike race with a bunch of your friends, but your speed is determined by your blood sugar levels. Your blood sugar levels increase when you eat a bunch of food, so your speed increases. When your insulin increases, your blood sugar levels decrease, so your speed decreases. Now, people who are non-diabetic don't have to worry about this because they have a working pancreas, so they're basically on autopilot. Now, when you're at a consistently high speed and you're going down a super steep slope, it's going to be really dangerous. But if you're at a consistently slow speed, you're going to end up losing the race. Now imagine that whenever you want to change your speed, it takes 30 minutes and it costs 70 cents. That's how much time it takes and costs for an insulin shot to work. 22.9 million people in the US alone have diabetes, and 8.9 million people are still undiagnosed. The thing is, insulin is the only solution, and people with diabetes have to take it multiple times a day for the rest of their lives. Now, what if I told you there was an actual cure to diabetes? Introducing regenerative medicine. Now, before I give you the actual solution to how this works, let me give you a crash course in diabetes. Normally, your body controls the amount of glucose that goes from your blood to your cells with two hormones, glucagon and insulin. Glucagon and insulin are produced in your pancreas in clusters of cells called islets of Langerhans. Insulin is produced by the beta cells, which are in the center of the islets, and glucagon is created by the alpha cells, which are in the periphery of the islets. Insulin reduces the amount of glucose in your blood. They do this by attaching to the insulin receptors that are attached to your cell membrane of various insulin responsive tissues, like adipose tissue and muscle tissues. Once these insulin receptors are activated, they get vesicles that have glucose transporter to attach to the cell membrane, allowing glucose to flow from your cell to your blood. Now, glucagon increases the amount of glucose in your blood. So this means they do this by breaking down. They get the liver to break down specific molecules into glucose, and they break down the glucagon, which all goes to your blood. Now, diabetes is diagnosed when your blood sugar levels are too high. In type 1 diabetes, normally people have, in your immune system, you have your T cells, which attack your antigens. Now, sometimes antigens exist in your own cells, and we don't want T cells attacking our own cells, so that's why we have self-tolerance. However, people with type 1 diabetes don't have self-tolerance. They're born with a genetic abnormality. This means that eventually they will target all the beta cells, and which will end up dying, and you won't have anything to produce insulin anymore. In type 2 diabetes, what happens is that your body is still creating insulin, however, you become insulin receptive, which means that your body just doesn't respond to the insulin anymore, so your beta cells start creating a lot more insulin. What happens is that they start getting really tired and end up dying off. In both cases, you just don't have enough insulin, and that's why you have to take insulin shots. It's the only solution right now, as I mentioned before. Now, there have been tries of getting pancreatic transplants inside your body. However, this doesn't work, and it's inefficient because it requires multiple donors. And because of the amount of people that actually have diabetes, it's not scalable. Now, with the solution of regenerative medicine, there are two major methods that have been tried on rodents and have been successful. So there's the ex vivo approach and the in vivo approach. The ex vivo approach creates the beta cells outside of the body and transplant them inside. Now, in the in vivo approach, these beta cells are recreated inside the pancreas using gene introduction or differentiation methods. The in vivo approach is beneficial because there are no ethical issues into worrying about where the stem cell has come from. In the ex vivo approach, there are three types of cells that needs to be created. There is the beta cells, there are the immune cells that are destroying the beta cells, and the thymus cells, which have to educate the immune system which cells to attack and which cells not to attack. Now, the embryonic stem cells are differentiated into the beta cells. This is very difficult because scientists have to figure out the exact signals for these embryonic stem cells to differentiate into the beta cells, and not just a normal neuron cell or a muscle cell, for example. Now, this seems simple enough, but stem cell research still has to come a really long way for it to actually work. For one thing, the insulin isn't produced continuously from the beta cells. It comes out in pulses. And there's a second layer of complexity when it comes to all the interactions of these cells that happens in the pancreas. But when the stem cell research is good enough, we can have a real cure for diabetes. You don't have to worry about changing your speed all the time. You'll be on autopilot, just like everyone else.